When a load is applied to a compression spring, it contracts, while an extension spring expands when pulled. They make compression and extension springs from steel wire. The diameter and qualities of the wire can vary depending on the end use of the spring. Spooled onto a reel, the wire uncoils, pulled by rollers leading to the forming machine. Guide rollers steer it in the right direction, as does this aperture. Numerous feed rollers push the wire towards computerized forming tools. They pause to allow the tools to do their work, and then they resume to supply wire for the next spring. Ahead, other rollers push the wire around a mandrel and coil it into an extension spring. A little arm at the side controls the diameter, and another tool cuts it to length. The forming process has caused internal stresses. To remove those stresses, they heat treat the springs. These compression springs have been formed differently, and we'll have more on that later. Out of the oven, the springs travel through a cooling chamber. The heating and controlled cooling improves the physical properties. They emerge better able to withstand repeated compression. With internal stresses relieved, attention now turns to the outer surface of the steel springs. A rack conveyor dips these extension springs into a vat of water-based paint. The paint seeps into the crevices of the coils, providing even paint coverage inside and out. The rack conveyor then takes the painted springs on a 10-minute looped trip through an oven. This bakes the paint onto the steel, providing a corrosion-resistant finish. This is before and after painting. These truck suspension springs are formed differently. They're a compression design and much larger. A worker heats the end of a steel rod in a furnace. He then inserts it between forming tools to taper it. This taper will allow the completed spring to sit upright. The entire rod goes into the furnace that's fired to 980 degrees Celsius. Red hot and malleable, the rod exits the furnace. A worker transfers it to the forming mandrel. The mandrel spins to wind the soft steel wire around it. This transforms the straight steel rod into a spring. A worker places the spring in a bucket that lifts it up to an oil bath. The bath quenches and hardens the steel. The spring then travels through a furnace, and this burns off quenching oil residue. A worker inserts the compression springs in a revolving fixture, with the ends of the springs protruding. As the fixture revolves, grinding wheels remove material to flatten the exposed ends. This flattened profile is another way to ensure that the springs will sit upright. The operator measures the height of the spring to confirm that the correct amount of material has been ground off. Here, you can see the difference the grinding has made. The next machine removes surface flaws. A worker places the spring inside. The spring spins while fine steel shot rains down on it. It's an abrasive that sands away imperfections. You can see the difference this makes in the spring on the right. The exposure to heat has made the steel wire more elastic. In the next operation, they set the compression and consequently the height. A press squeezes the coils until the desired amount of compression is achieved. After the spring has been painted, they stamp the company name and model information onto the springs. 2 hours in the making, they're ready for some flex time.